All right, we'll get back to section 5.4 here. So I want to look at solving systems by using matrices, or the Gaussian elimination method. That's the same thing. In this example, suppose that we want to solve the system, which is given by the equations 2x plus 5y equals 5, and then x minus 4y equals 9. Okay. We're going to solve by using matrices. So the first thing that we need is an augmented matrix. Okay, so I have the matrix given by 2, 5, and 5 for row 1. And then row 2, I'm looking at 1, -4, and 9. Okay, so this is the augmented matrix that we need to solve. Now the plan, like I said, is we're trying to get this into row echelon form. Okay, so 1's down the diagonal and 0 is in the lower triangular part there. Okay, well, I'm allowed to switch any two rows I want. So the first thing I'm going to do is get a 1 in the upper left-hand corner. That is always going to be the first step. Get a 1 in the upper left-hand corner. And we have this 1 down here, so if we switch row 1 and 2, then that'll do it. Okay, so the new matrix then would be the rows 1, -4, and 9 in row 1. And then row 2, we have 2, 5, and 5. Okay, so we have the 1 in the upper left-hand corner. The next thing is we need a 0 right below that 1. So I work in terms of the columns. Okay, you get column 1 set, column 2 set, and column 3 set. It has to go in that order. If you go out of order, you're not going to get the right answer. Okay, so directly below this 1 here, this 2 needs to change into a 0. We'll get column 1 set. So I need a new row 2. How I'm going to change that 2 into a 0 is if we take -2 times row 1 and then add those numbers to row 2. Okay, so you guys will have to come up with the row operations here in solving matrices. Okay, so let's take -2 times row 1 plus row 2. Okay, -2 times 1 is -2, plus 2 is 0. -2 times -4 is 8, plus 5 is 13. And -2 times 9 is -18, plus 5 is -13. Okay, so we're almost in row echelon form. The last thing to do would be to get this 13 to be a 1. Well, I can multiply any row by a number, as long as it's not 0. So I'd say the next thing, we need a new row 2 here. And to get the new row 2, let's take 1/13 times row 2. Okay, so multiply all these numbers here by 1/13. 0 times anything is 0. 13 times 1/13 would be 1. And -13 times 1/13, that's -1. Okay, so now this matrix is in row echelon form. And now, when I convert this back into a system, I should know one of the variables at that point. Okay, so we'll go ahead and convert this back to a system. We have x minus 4y equals 9, and then y equals -1. Okay, so knowing y is -1 means I can get x now. We got x plus 4 equals 9. So when I subtract 4, it looks like x is 5 and y is -1. How do I know that that's right? I can plug it in and check. Okay, so let's check this. X is 5 and y is -1. So is it true that 10 minus 5 is 5? Yes. And x equals 5, y equals -1 down here. Is it also true that 5 plus 4 is 9? Yes. Okay, so we can go ahead and circle this result here. Okay, that's correct. Now, usually, whenever we have a 2 by 2 matrix, like what I gave you there, usually, and like if you're not told what method to use, I don't care what method you use, but usually you're going to use either the substitution method or the elimination method. Okay. Matrices is an all right method, for a 2x2, but usually it takes a little longer to solve by using matrices. Now, whenever you have a 3x3, the fastest way to solve is to use matrices. Okay, so like in section 5.2, we were solving 3x3 systems using the elimination method repeatedly. Okay, and that's an all right method, but it's going to be faster to use matrices. The reason why I say it's faster is because we are only looking at the coefficients. I'm not writing down x and y and z each time, when I'm doing these raw operations. And all I'm doing is adding numbers. Okay, it's very easy to, slip up and one little mistake and there goes the whole problem. Okay, but so because matrices are kind of preferred for 3x3 and bigger systems, why don't we turn our attention now to 3x3 systems? I'm not going to give you any bigger than a 3x3, by the way. If you know how to solve a 2x2 and a 3x3, I think you got the idea. Okay, so just for whatever that's worth. So let's take a look at another example here. What if we want to solve the system, which is given by the equations negative 2x minus 3y plus z equals negative 15, x plus 2y minus 3z equals 15, and then 4x plus 9y minus 4z equals 49. Okay, solve the system. So we're going to solve by using matrices. And the first thing I need is a matrix, is an augmented matrix. So here it is. The top row is going to be negative 2, negative 3, 1, and negative 15. Row 2, we're looking at 1, 2, negative 3, and 15. And then row 3, we're looking at 4, 9, negative 4, and 49. Okay, so there's the matrix that we're working with there. Now, again, you have to work in terms of the columns. Get column 1 set, and then get column 2 set, and then get column 3 set. We're trying to get 1s down the diagonal and 0s in the lower triangular part there. Okay, so step 1, always with these, is going to be to get a 1 in the upper left-hand corner. Now, there's 2 ways that I can get a 1 in the upper left-hand corner. The easiest method is, well, I got a 1 down here, right? So let's go ahead and switch rows 1 and 2. Okay, so we have 1, 2, negative 3, and 15. And then negative 2, negative 3, 1, and negative 15. And then row 3 is just going to stay as is. So you got 4, 9, negative 4, and 49. Okay, that's one way that I can get this. Okay, another way that I can get a 1 in the upper left-hand corner from this matrix is I could multiply row 1 by negative 1/2. Now, if I do that, I'll get fractions involved in this right away. I don't like working with fractions. Okay, so, if you're solving by using matrices, you try to avoid creating fractions. Okay, you're making the problem more difficult than what needs to be now. Okay, so anyway, let's continue on. We got this matrix here. Now, directly below this 1, I need a 0 here and a 0 here. I'm going to do kind of like a 2 steps in 1 type thing, and we need a new row 2 and a new row 3. Okay, so to get the new row 2, let's take 2 times row 1 plus row 2, and then to get the new row 3, we'll take negative 4 times row 1 plus row 3. Okay, so I've got that written there, and well, here's the new matrix. So row 1 is going to stay as is. I got 1, 2, negative 3, and 15. And then row 2, we're taking 2 times row 1 plus row 2. Okay, so 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, plus negative 3 is 1. 2 times negative 3 is negative 6, plus 1 is negative 5. And 2 times 15 is 30, plus negative 15, that's 15. So that'd be row 2. To get the new row 3, I'm supposed to take negative 4 times row 1 plus row 3. Okay, so let's do that. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 2 is negative 8, plus 9 is 1. Negative 4 times negative 3 is 12, plus negative 4 is 8. And negative 4 times 15 is negative 60, plus 49 is negative 11. Okay, and so here's where I'm at right now. So column 1 is all done. Okay, now the next thing that I'm going to do is I need a 1 in the middle of the matrix. I already have that. If I did not have this number being a 1, though, that would be the next step. Okay, so because we've already got a 1 here, now directly below the 1, I need this 1 to be a 0. Okay, so I'm going to do something to row 3. I need this 1 here to be a 0. What I'm going to do is I'm going to take row 2 minus row 3. By the way, I cannot do anything with row 1. If I do anything with row 1, and then I'm adding these numbers to row 3, then the 0 here isn't 0 anymore, and that's a problem. Okay, so again, once you have the columns set, don't change the numbers, in the columns. You'll get a wrong answer there. Okay, so we need to take row 2 minus row 3. Okay, rows 1 and 2 are going to stay the same. Okay, we're getting a new row 3. So to get the new row 3, take row 2 minus row 3. Okay, so 0 minus 0 is 0. 1 minus 1 is 0. Negative 5 minus 8 is negative 13. And then 15 minus negative 11 is 26. Okay, now all I'm doing is I'm adding numbers here. Okay, it's very easy to slip up or get something wrong, or there goes the whole problem. But keep in mind that your answers are going to be nice numbers. Okay, so you're not going to get weirdo numbers. Okay, or if you get weirdo numbers, like I would go back and check that you did the problem right. Okay, so now this negative 13 has to be a 1. Well, I'll need to do something to row 3. And let's take row 3 and multiply that by negative 1/13. Okay, that'll make a 1 here. So rows 1 and 2 are going to stay the same. In row 3, I'm taking all these numbers and multiplying them by negative 1/13. 0 times anything is 0. So I got 0, 0, and then negative 13 times negative 1/13, that's 1. Negative 1/13 times 26 is negative 2. Okay, now I'm in row echelon form. So now I've got 1s down the diagonal and 0s in the lower triangular part here. So now I'm ready to convert this back to a system, and I should know one of the variables at that point. Okay, so I'm looking at x plus 2y minus 3z equal 15. Okay, and then y minus 5z equal 15. And then z equals negative 2. So knowing that z is negative 2 means that I can now backtrack to get y and x. If z is negative 2, we have y minus 5 times negative 2 equals 15, or y plus 10 equals 15. When we subtract 10, it looks like y is 5. Okay, and then knowing that z is negative 2 and y is 5 means we can get x Using this equation here, we got x plus 2 times, it should be 2 times 5. I don't know why that's a negative there. 2 times 5. And then minus 3 times negative 2. Okay, so let's see, 10 plus 6 is 16. And when I subtract 16 from both sides, 15 minus 16 is negative 1 for x. So I think that the answer is x equals negative 1, y equals 5, and z equals negative 2. How do I know that that's right? Well, let's plug it in and check. Okay, so is it true that negative 2 times negative 1, that's 2, minus 15, that's negative 13. Minus 2, that's negative 15. That looks good. Okay. And is it also true that negative 1 plus 10 is 9? Plus 6 is 15. That looks good. Okay. And is it also true that negative 4 plus 45, that's 41, plus 8 is 49? Yeah, so that's what I'm getting there. So yeah, that's the right answer. Okay, x is negative 1, y is 5, and z is negative 2. Okay. All right, we'll go ahead and stop the video right there, and I'll pick up with this example in the next one.